So without further ado, the man himself, Climate Interactive's one and only, you'll soon see why it's called Climate Interactive. So I won't waste time trying to describe it. You have to see it to believe it. So Drew, please take it away.
All right. Thank you, John. Thank you. Thank you, John and Holmes and Rachel and this whole community. It's been so welcoming, and I just had a great day. You guys are so organized. It's amazing what a great visit a visitor has.
It's Rachel and Holmes. I'm terrible.
All right. My name is Drew Jones, and I'm the co-founder of Climate Interactive. And we work closely with MIT and the Sloan School's Climate Pathways project with this simulator En-ROADS, trying to address the climate change challenge. We're funded by this group of philanthropists and donors from around the world who want to see us address climate fully. We're a non-profit think tank and a climate tech organization. And our vision is to see greenhouse gas emissions, the pollution that causes climate change, falling rapidly with equitable policy. I'll show you a little bit more of how we do that, but like John warned you, this is interactive. So I want to hear kind of your views of where you are about this whole climate challenge. And so grab your phones, pull out your phones, and scan that QR code. You're going to do a poll. And you can either scan that or send this message, Climate Inter 935, to this number, 22333. Or you can open it, if you have the laptop in the front there, another browser window. At the top it says pollev.com. But please connect to this. We're going to use polling a couple times. If you're next to somebody, and if you don't want to connect, and you're next to someone, you can whisper in their ear what you'd really like to see. And we're going to ask this question, I am what about climate change? If you see a word here that you like, type it again exactly like that, without caps or with caps, whatever, and it'll get bigger. Pessimistic, concerned, alarmed, pessimistic, concerned, hopeful, anxious, passionate, concerned. If you're just doing this, again, here's the QR code. Take a picture of that. Answer the poll. There it is. I want to give these two just a chance to take a picture. Take your picture, and I'll go back and we'll see what people are writing. Concerned, alarmed, worried, upset, depressed, motivated, scared, pessimistic, confused, another passionate, concerned, optimistic, hungry. I am hungry about climate change. That's a good one. Apoplectic. That's a $25 word there. Apoplectic, about enthusiastic, scared, worried, anxious. But you see the biggest word here is this concerned, alarmed, motivated. Concerned, alarmed, passionate. Skeptic, upset, hungry, deeply. And if you do, with all of these, if you have two words, hyphenate them and they'll stick together and get bigger. Come on in. If you're just joining, you're fine. I understand why. Know anyone in Houston last Friday? These winds hitting Houston, an extreme weather event, $5 to $7 billion of damage from extreme weather in one day, fueled, they believe, a bit more by climate change. It's understandable why many of you would say at least concerned, alarmed, worried, but also motivated and passionate. Concerned. Another reason about concern might be that when we look to the future, the world scientists were asked, hey, if we implemented policies around the world, where would greenhouse gas emissions, the pollution of climate change, be headed? Here is the last 20 years, the growth of primarily coal, oil, and gas, methane, deforestation. Here's the greenhouse gas emissions. They were asked, what if we implemented the policies that are currently on the books in countries and businesses? And that red line is where the world scientists think we're headed. Where do we need to be headed? is to limit warming down this green path or the blue path. This is from the recent International Governmental Panel on Climate Change. It's called AR6, if you want to go find the report behind this. So the reason to be concerned and worried is if all we do is implement the ideas that are around today, where we're headed is the red line, and the gap is closing this gap. How do we close that gap? I just heard from Professor Yi Shui about the Sustainability Accelerator, about Precourt, all the innovation that's happening here on campus. Ideas about how we close this gap. And that's the good news. There are so many proposed approaches to closing that gap to get emissions to, as I said in our mission, Climate Interactive, falling rapidly. I want to hear what you're hearing when it comes to those kinds of proposals. So what are you hearing? Same setup with the poll. What are the solutions that people are proposing to global decision makers? And think of this is not California or the US. This challenge will be met in China, India, Indonesia, Brazil, South Africa, many of the fast-growing nations around the world. What is being proposed? Again, if you have two words, put a hyphen in there so that you'll see it all as one. Carbon price, sustainable, space, go to space, is that what that is? Offsets, regulation, slow down, address consumption, carbon tax, nothing good, there are no good solutions, someone's saying. Efficiency, address consumption, address risk, recycling, space. What are the other solutions that are being proposed that would close the gap between that red line down towards the green and the blue path? What are others? You can propose more than one. Type in another one. Carbon tax right now is the biggest. Renewable energy, corporate accountability, regulation, climate adaptation, electrification, emit more, nothing good. Carbon capture and storage, direct air capture, CCS, fossil energy, fusion, investment in a new technology like fusion. Renewables, now the biggest one, carbon tax and renewables. Well, I think here is the world that you hear proposed, the world of options proposed to top decision makers around the world. And it's wonderful, the abundance of possibilities. It also, from talking to a lot of decision makers, can be daunting, just the breadth of possibilities here. I talked to someone in the financial services industry looking at the $41 trillion gap in climate finance. McKinsey calculated that was how much money by 2030 needs to be invested. And she said one reason that people are holding back on investments in climate finance is that there's uncertainty about which will be the bets that win and not wanting to make the wrong bet. Algal biofuels in the 1990s was Exxon's big approach. 14 years and millions of dollars later, canceled program. You did not want to make your bet on algal biofuels in the 1990s as the solution. When they look at this breadth of possibilities, many investors are saying, I don't know what's really needed and what is actually not as needed. And governments and people, policymakers around the world in the same way. How do you look at all this and in your head do the math on what are the higher priorities and what are the lower priorities? Well, luckily there's research. Research, studies, articles, I've read many of them. You see the PDFs that say, here's what we really need to do. The challenge, though, and my colleague John Sturmat at MIT said it best, is that for many policymakers, research shows that showing people research doesn't work. Anyone else seen this? Research shows that just showing people research doesn't work. We've known what it's going to take for 30 years, arguably longer than that. We need to come up with better ways to learn insights and put it in a form to leaders around the world that actually changes behavior. That's the challenge of Climate Interactive. That's the challenge that we and our partners at the Sloan School of Management have picked up. How do you bring ideas in ways that actually change behavior? We've been experimenting for years with this, and I have a picture from last Thursday of what we're finding works. What works is here, 41 members of U.S. Congress, this is the House of Representatives, the Democratic caucus, inviting Professor John Sterman, who is one of the builders of this model, to host and facilitate a conversation amongst peers and colleagues backed by and grounded in the best available science. This is not Professor Sterman saying, here's what you need to do to close the gap between the red line and the green line and the blue line. This is, so everybody, what shall we do? What do we think is going to work? And then I've done it many times with Congress people. It's interesting. They don't look at me as a facilitator. They look at each other, because learning is a social experience, particularly in a politically charged space. So we have to bring a simulator that is supporting a conversation where all the equations are shared online, open source, replicable. Assumptions are changeable, and people have access to these tools, frankly, in 20 languages, so that it can be used all around the world. So our experiment is in supporting top decision makers to make the distinction between high leverage and low leverage policies. Here in groups, sometimes one-on-one, and bipartisan, rigorously bipartisan. This is a meeting I had at the Aspen Institute with Representative John Curtis of Utah, head of the the Conservative Climate Caucus. And he said, what I like about En-ROADS, it can support a thoughtful conversation. But of course, not just with policymakers, but in the business world, in the education world, and in other areas such as that. So what I'd love to bring you is, if that's the promise, that's what we're aiming for. I'm going to help you have the experience of the microcosm, you could call it, of what we've been doing with top decision makers like there in Congress. Let's play together and experience what they go through when you think about closing that gap between that red line and the blue and the green here with our simulator, En-ROADS. En-ROADS, of course, here it is. We've talked about how it runs, that it's particularly fast. You need it to run very quickly so that if you make a change in it, you're very immediately going to see what is the impact on the energy mix, on greenhouse gases, on temperature, etc. So imagine yourself, members of Congress, thinking about global strategy. Note, they're in charge of the United States, so they have to think globally and then apply these ideas wherever they are. But the first thing that happens is they don't start talking about buildings and industry energy efficiency. The first thing that happens is, what about my home district? Wait, this is here and now. I don't want to talk about solving the problem in the future. Wait, what is going on here and now? Why, here in Houston, did we just see what we saw with extreme weather events? So, what is the coastal area where you're concerned about climate change? Anybody here? What's a city that you might want to go look at if you were exploring the impacts of climate change?
New York.
New York, yeah.
Miami.
New York and Miami. It happens, this is open to Miami. I'm going to open this other one. We can look at both. So we connected the model to Climate Central's maps of sea level rise. And here you type in New York, and we'll be able to go and look at that area. Blue areas are at risk to sea level rise. This is around Miami Beach. I'm going to make it really big. You've seen some of these maps. Don't look at them too long. Fear doesn't help us particularly. That's a bit much to see where it's headed. We could explore storm surges or the long-term equilibrium sea level rise. But let's just go focus in here, Miami Beach. The blue areas by 2100 are at risk to sea level rise. Why? Mostly because warm oceans are bigger, and then you also have the melting of land ice. But that's one of the things that we face by 2100, and we could go and see, well, what's going on by 2050 or another decade. Decision makers want to get grounded in what's coming soonish and what is here and what the impacts are. The other is they're going to want to go see other things that matter to them. Biodiversity. We're concerned about mammals. 24% of species losing more than half of their range. The blue line will capture the scenario that we're about to create. Can we do better? Of course, there are many other impacts you ought to get grounded in as a decision maker before starting to work on avoiding these problems overall. Okay, we're going to test one action. I saw the word fusion. All the excitement about maybe a new technology could solve this problem pretty significantly. So I'd like you to start thinking about testing it in the model and, frankly, testing it in your own mental model, the one that you make 98% of decisions with every day, the one between your ears. If we had fusion, cheaper than coal, spreading around the world, competing with coal and keep competing with gas and renewables, imagine what would happen to this graph. The one on the left shows you global sources of primary energy. 2000 to 2100, we're going to land. Fusion's going to arrive in a world with continuing coal, oil in red, natural gas in blue, renewables, wind and solar. You see how that wedge is expanding? It's expanding because that area is growing. Bioenergy, and then nuclear on top. The other assumptions that are behind this, you could go explore yourself. Of course, the model is free. You could go open it up and try it yourself. But behind it, of course, we have to make assumptions about what's going to happen to population, GDP per capita, population that you could assume will be lower or higher. Look in the top left there. We could imagine different worlds for what population does, or economic growth could be lower or higher. Assumptions about improvements to energy efficiency that would lead the energy intensity of the global economy to be falling over time as we transfer from manufacturing towards service industries, as technologies get more efficient. The energy intensity, the exajoules of energy per $1 trillion, falling steadily over time. And then finally, the carbon intensity. Based on the fuel mix, how much wind and solar, coal and gas and oil, falling over time as we decarbonize. Multiply the four together and you get overall emissions. Those are the assumptions behind it. And we're going to drop fusion into that world. And I think I made another poll for you. Imagine for a second that we did succeed at that. That next week, fusion comes out of the lab. You see the headlines, big news, it works. What will the temperature, I'm not going to let you see each other actually. What do you think the scenario's temperature will be after moving the slider? Over 3.3? That is no change, or it actually gets worse. 3.1 to 3.3, 2.7 to 3, 2.3 to 2.6, 2 to 2.2, or actually, you know what? Problem solved. We met the Paris Agreement. We limited warming to well below 2 degrees, and it will solve the problem. So type in there your answer. This is critical. This is not an answer machine. It is a thinking tool. It is to spark your own mental simulation and then test your mental simulation against the computer simulation and see if there's an opportunity to adjust your own thinking closer to what a computer model, which handles feedbacks and delays and interdependencies so well. Make your guess. Make your guess. 26 of you have made your guess. Put yourself on the line, and here it comes. What did you think? 2.7 to 3.0 got almost half. 2.7 to 3.0. Some people thought it would make things worse. No one thought it was a, quote, silver bullet. But many of you thought maybe it gets close to 2. Okay, 2 points. So remember that, 2.7 to 3. That was the mental simulation of the most of you. We're going to go back in here. And are you ready? And we keep it pretty simple. You notice designed for someone who doesn't love numbers. There are no numbers below here. Because we want to reach such a range of people, we can just go here and hit the button up there to say we're going to imagine it and see what happens. Are you ready? Drum roll and boom. Okay, let's see. I'm going to hit the replay button. Look at the orange in the top left. That is the growth of new zero carbon. In this case, fusion. It could have been huge geothermal. It could have been thorium fission, perhaps. And out here in the top right, you can see what happens to greenhouse gas net emissions. And it went from 3.3 to 3.2. So many of you matched. I'm not saying you were correct. You matched what our simulation is showing. So anybody, from what you can tell so far, what's the reason that it didn't do as much as we would dream? Anyone see just from these graphs so far? What do you see that might be a reason that it didn't help as much as some thought with the 2.7 to 3? Yeah?
You're eating up the renewables green area.
What about the renewables?
You're eating up that.
You are eating up the renewables. Let's go see. Run it again. I didn't notice that. Look at the top. Okay. Yeah. The fusion is competing not just, as you would like, with coal and not just with natural gas, as you would like. See the blue line? You can see less blue. The blue line is lower, less natural gas. But it's also going to compete with the incredibly large anticipated growth that we're already counting on in renewables. It is eating up the renewables. Reason 1. What's another thing you say of just reasons why it's not helping as much as we would dream?
Takes too long.
It takes too long. Now is better than new, said Jonathan Foley. Now is better than new when it comes to time delays. Look at this 2050 or so. Now, we assumed a 20-year commercialization delay. Now, you could say, Drew, why are you sandbagging it? You're cheating here. You just don't want it to work. So in that kind of moment, we say 20 years, maybe it won't take 20 years. So let's assume it does happen next week. This is where you want to get more nuance with your test. And you say, well, what if it does grow in 2024 and it's not 20 years? Watch in the top right as it moves back, 14, 10, maybe it's going to take 9 years. This is going to be on like the vaccine time frame, like we're just going to do this really quickly. I don't know, maybe it's going to take 5 years, not 20. But still, it's taking some time, not just to arrive, but you have invested in coal, oil, and gas infrastructure that's 30 years in its time frame. It takes a long time for that old stuff to retired out, to have the new stuff come in that's lower carbon. There are long time delays. Now is better than new. Deploying things that we have today that lead us to to reduce emissions from coal, oil, and gas. So that's another reason. Another one that you might not see, but why does it spread around the world? It spreads around the world because it is so inexpensive. Cost of energy overall goes down. Great for equity. We like this. When cost of energy goes down, what happens to the incentive for energy efficiency and energy conservation? Yeah, there's a slight boost. You see that the final energy consumption is a little bit higher. There's a feedback process there. It doesn't double, but there's a small boost to energy consumption because of the disincentive for energy efficiency because of the price. Okay, several reasons why this may not deliver as much of the result as we want. And yet, we might need it. What would really help it? Electrification would help it a good bit. So if we electrified as well, maybe these two things could work together in the longer term. But clearly this should guide us. Hey, what else do we need to do? This certainly isn't the one solution that we often dream of. So, if not this, what are the things that when you see here, and I'm going to let you can change taxing of coal, oil, and gas, bioenergy, or encouraging them, renewables, either way. Underneath there, you can have hydrogen storage. It's underneath this area, nuclear, set carbon price, energy efficiency in buildings and industry and electrification, transport, carbon removal, nature-based with biochar, ag soil carbon, plant trees, or technological-based, direct air capture, agricultural emissions on methane and nitrous oxide and F-gases, waste and leakage, methane in those areas, or cutting deforestation. You can also change diets and food waste. So turn to the person near you, find somebody and tell them, I'm going to tell Drew to do this, because I think, given what I just saw, this is what it's going to be about. Take just a minute, and if you're far away, really scoot over, find somebody to talk to, and say, I would like to propose this. Turn to someone near you. Okay, I didn't give you enough time. Definitely not enough time. However, let's hear your ideas. So, briefly, someone call out what did you just talk about? What's it going to take?
Carbon price.
Carbon price. Carbon price. Any dollars you like? What do you like? You know these numbers? Right now, it's set at 5. 25% of global emissions have a carbon price. The average is about $20 a ton. Many cities in China, Europe, parts of the United States. It's at 5. What do you like? $100 a ton adds about 92 cents to a gallon of gas here in the US. You ready? Do your mental simulation. You got a number? 3.3 goes where? Everybody do it. Think the number. Actually, hold up your hands. The number of tenths of a degree it's going to drop. If it's going to go to 3.2, you hold up 1 for 0.1. He's got 4 fingers. He thinks it's going to go to 2.9. Half a degree, 5, 1. Everyone hold up your hand. Put your hand in the air. Now make the fingers of how many tenths of a degree you would mentally simulate $100 a ton. 5, 3, 4, 5, 5, 3, 3, 2. Just note, okay, put your hands down. Notice how much diversity we have in the understanding of what policy interventions, even that have been studied for so long, how much diversity we have about the understanding of what is high priority and low. We need simulations. All right, $100 a ton, 0.6. 0.6. 0.6. Why? Well, it led us to burn a lot less coal, oil, and gas. See those black, brown, red, and blue areas? What happened to energy consumption? Remember last time? It went up. Well, in this case, energy is a little more expensive. Major equity problem, note. Major. What do we do about getting people the energy that they need for transportation in their homes? However, how about the incentive for energy efficiency and energy consumption goes down a little bit more? Okay, but this, let's do some more things. Carbon price. What else? What else?
Lots of energy efficiency.
Lots of energy efficiency. Thank you, Dr. Orr. Let's go do it. Buildings and energy. I'm not going to dig in. We're going to do this at the surface level. But here we go. We're boosting insulation, performance standards, motors, etc. Reducing energy demand and curbing it significantly. Another point, too. It does more without a carbon price. Another point, too. And in transport, urban design, vehicles, scooters, buses, trains, all of this, another 0.1. What else after a lot of energy efficiency from Dr. Orr? What else? Yes?
Changing the way we produce food, nature-based solutions.
The way that we produce food. I'm going to go under here, and we're going to look and see in the bottom right, methane emissions. Now, methane emissions are already so much lower. What, you see this graph right here? Energy, agriculture, and waste, the three big sources of methane emissions. Why is energy production emissions of methane going down already? Why? Because we have a carbon price and we have energy efficiency that leads us to produce a lot less natural gas. The best way to cut leakage of natural gas is to not produce natural gas. So less natural gas, and what if we are able to capture more of the leakage? That's going to change. Well, actually, you didn't talk about that, but I will do it over here. If we reduce waste and leakage of it, that's another 0.1. Here with agricultural emissions from agriculture and nitrous oxide from agriculture, 0.2 degrees. We're already at 2.1 by addressing that. You also mentioned carbon removal. Nature-based solutions, some of them in here. We can plant some trees. We can also have agricultural soil carbon. And now we're at 2. What else do we do? Yes? Electrification, particularly with enough pressure and pressure on fossil fuels and decarbonization. That, we boost that in 2 areas. Now we already, boy, it doesn't give us a 0.1. Under other conditions without a carbon price, it does much more. What else? Yes?
CCS.
Can we do CCS? We are getting some CCS with a carbon price, and we're about to add more of that. Let me go see. I actually think it's in here a good bit already with a carbon price. So actually, yeah, we modeled it such that a carbon price pays for it. This is natural gas. This is gas CCS that got added because there was a carbon price that could pay for it. What else to get below 2 degrees? Cutting deforestation emissions. Cutting deforestation emissions, 1.9. And someone else said with nature, some of the diets, food from animals, food waste, and you're at 1.8 degrees. Below 2 degrees, what does it take to get to 1.5? A little bit more of everything, but I'm going to pause there. 1.8 degrees. How much better a future did you just create? What did we see? There's no one big thing that we're searching for. Fusion, even a carbon price, we're not searching for the one big thing. Instead, it takes many seeds to plant this garden. Many seeds across sectors, across scales, across gases, across approaches. We're seeing that it takes on fossil fuels, the huge driver, both the clean energy revolution, but also in this case, it took some direct pressure as well to get those emissions to fall rapidly enough. And most importantly, it's still possible to bend these curves towards not that red line I showed you before, but the green and blue that would get us below 2 degrees. It is still possible to make it happen. Going back over to these polls, I'm going to ask you another question. Another question. When you think about this and the possibilities and what's being done here at Stanford and around the world and spreading these ideas through group work like the Sustainability Accelerator and Pre-Court, the possibilities of getting to the rest of the world where so much of the future missions are, how are you about climate change? Go to the poll if you would. Answer the question. When you think about it, still pessimistic, cautiously hopeful. I get it. Intrigued, cautiously hopeful. Boy, that's pretty good. I'll take that. Motivated, energized. Pessimistic, still pessimistic. Realistic. More worried. You should be. Look seriously at the challenges we face. It's hard, hard work to implement that breadth of solutions. I get it. Pessimistic. Slightly something. Maybe slightly optimistic. Maybe because I see the quotes. Cautiously hopeful. Motivated. If you see a word you like, write it again. You can write it several times. You don't need just one answer. Intrigued. Realistic. Energized. Cautiously hopeful. Motivated. Realistic. Optimistic. Slightly optimistic. Still pessimistic. Motivated. More worried. Still skeptical. Absolutely. Any more answers? More worried, motivated, optimistic, cautiously hopeful, skeptical, still pessimistic, self-aware. Thank you. Okay. So what I'm laying out to you is the possibility of seeing the huge breadth of things that need to be done and are being posed to top decision makers, acknowledging that we need better accessible tools to allow us to test in real time, and certainly not in 30 minutes, but in a more drawn out, thoughtful inquiry where you're able actually to look under the hood, test assumptions, and think for yourself, grounded in a tool that is flexible to your thinking, but also fast enough to meet decision makers where they are. There is this potential now with these tools and others that are out there in the world. Overall, this is now available. It is free, online, 20 languages, mostly being used outside of the United States in other countries of the world. We have 780 people who have taken a free online course that you could go study to engage other people in schools all the way up to top decision makers. There's a game role-play version. We use it at Energy At here every September to welcome incoming students to pick up the simulator in teams of 5, play with it themselves, and come up with scenarios that they'd like to see, and look under the hood a bit and test things that are out there. But overall, here's this offer to you of a tool that you can use and that we hope the world uses to make sure that we bend that curve from that red line all the way down to the green and the blue. It's not going to be easy. It's going to be worth it. Thank you very much, everybody.
Thanks, Drew. Now, as promised, back to you, Holmes.
Sure, thank you so much.
Yeah, all right.
I'm going to borrow that microphone if you want to be heard on the recording. Friends, I've heard Drew deliver his simulator talk a few times, and I find it always compelling because it doesn't necessarily need to be precise or accurate in its results to be motivating. And I think we saw that in the change between the first and the second response to the questions of what people feel about the options that are available for the challenges. One of the roles that I have at Stanford, there are a few, is, as John noted, to serve as the resident fellow for residential education in the Academic Theme House for Energy. This is an academic theme house that is Stanford's first academic theme house in science, technology, engineering, and math, and it was opened for the first time this past year. It was my great privilege to select the incoming class of residents including the 45 folks that are resident now out of 1/5 of the incoming undergraduate class that ranked it as their top 3 choices of housing. So it's a wonderful community, and I'm looking at 3 or 4 of the residents right here in front of us. But the person I'm going to introduce next is Rudrash Mohapatra. And Rudrash arrived from India with an interest in energy and sustainability that was sparked early in life by exposure and engagement in rural India. And before coming to Stanford, Drew Jones and the work with Climate Interactive had already reached him in India in an opportunity to become one of the ambassadors. And so to close out the seminar and to return you to Q&A to Drew, we wanted to hear first from a Stanford student who's taken on the challenge of learning the simulator and introducing it to other people. Rudrash Mohapatra.
Thank you, Holmes, and thank you, Drew. That was a really inspiring talk. I first became an En-ROADS Climate Ambassador 2 years ago as part of my scholarship program that was offered by the MIT Center for Systems Awareness, where we were given an opportunity to look at the En-ROADS simulator and get a systems awareness perspective on how climate change operates. Before coming into the En-ROADS simulator, I first felt that climate change was just a scientific problem, that it needed to be solved using science and math and all those things. But after working with the simulator with a bunch of my peers, I came to realize that climate change is not just a scientific problem. It's a social and an economic problem as well. And we need various different factors contributing cumulatively towards solving it. And one of the main reasons I became an En-ROADS Climate Ambassador was because of the change in perspective that I noticed in myself after interacting with the simulator. As a climate ambassador, we have to go through a series of training where we get to be more acquainted with the simulator itself than in our group discussions. And over there, we come to know just how much work goes behind making the simulator, all the math that goes behind it, and more. And so one thing that I noticed in our group discussions was that students that went into the group discussions came out more connected with climate change and with a much more different perspective. So, for example, in our group discussions, we had people from India, from Nepal, from Japan, from the US, and Germany. And all of them had very different ideas about what it meant to have good climate policies, what it meant to be a good approach towards solving climate change. And all of them were influenced by their experiences growing up, in their experiences in their own countries and globally. And so this change is what inspired me to become an En-ROADS Climate Ambassador. And in my role, I have mainly spoken with high school students, with students from my high school, with students in my cohort at Stanford and at my scholarship as well. And one of the great things that I noticed about this simulator, as we have noticed before, is that it's a very interactive simulator. Human beings are visual learners. If you provide them with a bunch of numbers and statistics, the problem becomes alienated. And we do not want to reduce climate change, which is a social problem, down to just numbers. Climate change affects thousands, if not millions of people across the world every single day. And we do not want to reduce people to just statistics. We want to view them as people. And being able to see them as in a more visual and more interactive manner is one of the biggest strengths of the simulator, I feel. And in this manner, I see that to solve the defining problem of the 21st century, that is climate change, we need a much better public dissemination of knowledge, and that is what the simulator excels at. Thank you.
Thanks, Rudrash. That was just fantastic. Drew, do you agree?
Yes. I'm so thrilled. I didn't know you'd be here. It's great to see that you use the simulator.
Excellent, excellent.
So questions?
Yeah.
Time for questions?
Yeah, we have about five minutes, maybe a little bit more.
Yeah, please.
I have a question. This is very impressive and very innovative.
Thank you.
All the scenarios you put on here on the screen is more on the climate mitigation. There is another great aspect of the climate change is on the climate adaptation.
Absolutely.
And the essence of the climate adaptation is actually the early warning system, which means what measures we need to take in order to prevent the risks. You mentioned about the Houston risks, right?
Yeah.
And my question to you is it possible that you could add the climate adaptation, the risk prevention or risk assessment and mitigation measures on top of the mitigation side?
Yeah. So can we add adaptation and other measures like that? That is the area of the biggest growth right now in En-ROADS. I showed you at the start some of these impacts. I think, did we, with overall species losing more than 50% of their range, instead of a 51% drop, only 14 under this scenario. And yet, for adaptation, still 14. How do we prepare invertebrates for what's going on? Mammals, still a 7% drop. That's the adaptation challenge. It's not a bigger adaptation challenge with mitigation. It's less, but it is still notable, and there are dynamics to it, and there are many issues. And, well, the good news in Miami Beach is that there are areas that are green. And green would have been at risk to sea level rise under the beginning scenario that are not at risk to sea level rise because of all the mitigation. So you're helping people with some nuance around how much adaptation is needed at what time, given the world's success at reducing emissions. And right now we're adding health, we're adding nature impacts, and we're raising money to add many more, such as how much lithium we need to dig up for the clean energy revolution, et cetera. Trying to make the model better and better, both on the adaptation side, the costs of all of the interventions that we make, and resilience and other factors like that. Other questions?
Thank you for this example of the rising sea level. Is there also a tool to visualize what are the effects of extreme storms? Because that will happen much earlier.
Houston, last Friday, my goodness. Yes, and we're now pulling in maps from Probable Futures is another place that's taking the general circulation model data and putting it into map form. We have added more data on extreme heat events. In 1850 to 1900, 1 out of 50 years had an extreme heat event. Today, it's 8 out of 50. We would be headed at 30, but with the mitigation, it's only heading towards 12. Again, it doesn't erase the problem, but it helps us understand how much of a contribution to avoided adaptation do you get from mitigation. We need to add more information. So it's really a comprehensive view from mitigation through to coping with the world that we are creating no matter what. Others, yes?
I do not see the button or slider for geoengineering. There has been some research done in that area already.
Yes, yes. So there are ideas in two big areas. Spraying sulfate aerosols into the stratosphere to reflect light. Solar radiation management. There's also marine cloud brightening, the idea of ships putting more moisture, water vapor in the air or over the oceans to reflect light. We're thinking maybe of adding that to the model. What do you think? We can't show any of the costs or the possible downsides of changing the global biogeochemical system with a huge intervention such as sulfate aerosols in the stratosphere. We debate it a lot because we could add it to the model. We haven't yet. What we're thinking is maybe you need to spend 20 hours with the model and then you get an upcode and then you're ready to come in because it works like a thermostat. You're just like, okay, airplanes, spray some sulfate aerosols, temperature goes down. It seems like just moving a thermostat if we were to build it. But with the responsible management and the right funder, we'd consider it. Other questions?
I think we're just about out of time. I think you wore the audience out with all the questions. Interactive.
It's too much. All right.
So with that said, let's thank Drew and Holmes and Rudresh one last time, and the audience for great questions and great interaction one last time. Thank you very much, Drew.
Thank you.